number one hint for drawing in 3 dimensions? What do? Do you remember? As few lines as possible. The fewer the lines, the better, right? So that's just one rectangle spun right there. Zach, could you get the door, please? Thanks. So what's going on here? You're adding up all of those those disks. You're adding up all of those disks. And the lower limit of integration, what's the lower limit of integration going to be? Well, it's going to be negative. It's going to be -1 because it tells you that, that's where the boundary is. It also is where that line hits the x-axis. So it's starting at -1 right there, and then where's it going to? It's going all the way to 5, which is right here. So there's your 5. So what's that formula that we use to find the the volume of a cylinder? Pi r squared h, right? In this case, what does h correlate to? H is the dx. That's the width of each of these. The dx is right here. It's infinitesimally small. Everybody sees that right there? That's the height. It's very small. That's the whole point. And then the radius in this case is the distance from the x-axis up. It's about what you're rotating it from. So what is this height right here? Well, it depends on x. It depends on x. And in this case, what is it? It is x plus 1. So there's the x plus 1 right there. So if you wanted that point, you would plug in x, and you would get out what? X plus 1. So you have to do what to the radius? What do you have to do to the radius? What are we doing to the radius right there? We are squaring it. So that's why the square is right there. And now you just end up with this thing right here, this integral. And do you need U-substitution to solve this? Do you need U-substitution to solve this? No, you can just expand at this point. If you expand this, you end up with a polynomial that you can just flat out integrate straight out. And then if you did it by hand, you end up with 72 pi right there. What do you think? I've asked this many times. Where do you think most people make their mistakes on this question? The algebra right here. By far, the most common place, if you did this by hand, people make mistakes, is right there. Absolutely. If this was if I gave this to you on a calculator test, if you were allowed to use a calculator on a question like this, I would expect you to set this up right here and then just use your calculator. If you have your calculator, I want you to show me what integral you would integrate and then just use your calculator. Absolutely. You can still do it in terms of pi. Pull the pi out, and then you can still get exactly 72 pi. Because you do the integral of that with pi on the outside, you'll get 72, so the answer is going to be 72 pi. Does that make sense, everybody, about using your calculator at that point? Maybe, kind of, sort of. The picture. How do we feel about this picture? How do you feel about this picture, Nick? Does this picture look okay? It's y equals e to the x. So does it, I mean, it's zoomed out really far, but does it actually cross at 0 right here? No. What's that point where it crosses the x-axis? It's 0 comma what? Anybody remember? What's e to the 0? You know that. What's e to the 0? 1, yeah. The point is actually 0, 1 there, just to point that out. So what are we doing here? We have a very similar thing here, and I just lost this, I'm sorry. E to the, so this is our radius right here. That's our radius. Our radius is this distance right here. And again, what's the height? What's the height continue to be? Dx. So the height is e to the x. Sorry, the radius is e to the x, and the height of this disk is dx. So you're just integrating this right here. You're integrating that. So could you use U-substitution here? Sure. You could let u equal 2x, so you end up with this. Substitute back in, do the algebra, and you end up with this right here. This would be the exact answer. One thing you guys need to pay attention to is when I ask you for exact answers, you shouldn't be giving me decimals that are rounded. That's not exact. Exact means effectively do it by hand or only use your calculator when you can get exact numbers. Like this. Let's say that was the function. Are there functions that look like that? Yeah. So what do you do first? You take this and then you copy it over, but you're reflecting it over the what axis? Let's go over the x-axis, shall we? Let's rotate this. Let's rotate this left. Let's rotate this left, like this. Let's rotate it. Oh, I didn't want to do that. I want to delete this. I want to do this, sorry. Paste. And then I want to flip. What do I want to do? I want to flip what?
Flip horizontally.
Flip vertically. So then I take this, and what do I have right here? You see that, everybody? So that's if it was spun 180 degrees. So what do all of these washers look like? Well, you take one rectangle, and then what do you do with that rectangle? Draw it down here, and then if you're going to draw this, here is one. This is what happens when you spin. If you spin that one, you have a. Do you see it now? So you have how many of these?
A lot.
What happens as you draw more lines? It's really hard to see, right? So one thing you can do is you can draw it a little skinnier than that. Oh, that was not, it's too far back. You can go back, and there it is right there. So if I take this, one thing you can do is you can think of it like this. I'll do it with one of the highlighters. Here's one washer. Here's another washer, right? And there's another one right here, and then there's another one right here. You add them all together, and you end up with the volume of the whole shape. So the first thing I wanted you to do is graph this carefully, and most of you figured it out eventually. If you are lost on a graph, what can you always make? What can you always make? You can always make a what? Begins with a T. You can always make a table. You can always plot points. People eventually plotted points, which was really good. So like cosine of 0 is what? What is cosine of 0? 1. So it starts at 7. And what's cosine of pi? What's cosine of pi?
4. No.
No. What is cosine of pi?
0.
Nope.
1.
Is it 0? You've answered the
Oh,
question
cosine.
over there. What is cosine of pi?
Yeah,
-1.
Okay, we're going to try this
It
again,
is.
everybody. So it's 7 there, 0, 7. What point is this right here?
1.
How high is it though? Yeah, I put the pi in there, but how high is it?
1.
1. So this function goes down, and then what does it do? It goes back up. So we know that that point is 2 pi comma 7. So then once you draw that, if you're gonna rotate this thing, what do you do with what you've drawn right here? What do you do with this? What do you do with it? You do the same thing, but then what do you do? I'll just keep talking to myself. You flip it vertically like we did 2 seconds ago. It's fine. It's okay. I'll just keep talking to myself. I'm going to keep bringing this up. Bring this up. So this ends up right here. I made it a little bigger, unfortunately. So it's right there now. So then what do you draw in? Draw one what? Draw one. Well, first I wanted you to draw a, theoretically you're taking a rectangle like this. And if you were to rotate that, it's going to look like this, right? Can you see the rotation now?
Yes.
Okay. So now tell me what the integral is going to be. What is the integral going to be? The integral from what to what?
0 to pi.
0 to 2 pi of what?
3 cosine x plus 4.
3 cosine x plus 4 what? And there's two things still missing. What's missing?
Pi.
Pi and dx. Exactly. Dx. So if you factor the pi out, you end up with this. 0 to 2 pi of, that's the radius. Remember the radius is always squared? Remember we're adding this together, Nick? Pi r squared dx over and over and over again. So how would you go about solving this right here? What do you think?
W substitution.
You try W substitution, but when you're picking W, you're trying to find a function whose derivative is also there. Is the derivative of, can you think of anything that you can pick for W where the derivative is also there? No. So what do you think you have to use on this one? What?
Expansion.
So you would try expansion, but then you're going to get a cosine squared. Integrating cosine squared is actually really, really hard. So what do you think you have to use on this one? A calculator. Do that now. Use your calculator right now and give it to me to 3 decimal. These are your boundaries, and this is what you're rotating it around. Draw me what's going on. Draw me what's going on. Yeah, it's just 5. So in this case, you have 0 to 4 of pi times 5 squared dx. So what do you have here? 25 pi, 0 to 4 of dx. What's the integral of dx, Gabby? Just what? Yeah, just x. So you have 25 pi x from 0 to 4. So that's 25 pi times 4 minus 0. So what's that going to be? What's that going to be?
100.
100 pi. Yeah, that's it. Now, is there a quicker way to find the volume of a cylinder? Yeah, well, we know the volume of a cylinder. We just added an infinite number of cylinders together to get the volume of one cylinder, right? What's the volume of a cylinder? Pi r squared times the height. Well, that's what? Volume equals pi. What's the radius again? 5. And what's the height?
4.
Hey, does it come out to be the same thing? In this case, there's an easier way to do it because we have an equation for the volume of the actual shape. But what have we established? Does the upper boundary, does this boundary need to stay linear? Does that top boundary need to stay linear? Well, in this example it is, but could it be bouncy like the graph over there? Yeah, it could be bouncy, you could do anything you want. Does it change the method? No, it's the same method. Is that integral kind of nice right there? Yes, it is nice. It is very nice. Okay, so let's make it a little bit more challenging on your own. Please graph for me what's going on here. Draw me a nice picture of what's going on. Draw me a nice picture of what's going on. What points is that? Oh, come on, you can figure it out.
-4.
-4, right. So what do each of these washers look like now? Oh, this is really cool. Kind of looks like this. How's that washer look? Did I do okay there?
Yeah.
Is that better? What that's doing is the original region that you're rotating is this region right here. See this region right here? That's the region that's getting rotated. And when you rotate it, you end up with those washers. Does that make sense? Okay, so the question now is, Henry, what is the integral? Remember, we're integrating from 0 to what? 0 to what, Henry?
3.
Yes, 0 to 3, and it's pi r squared dx. In this case, what is the r value? Can someone tell me what the r value is? Be very careful about this. What is the r value on this one? What's the r value? The radius is right here. Here's the radius. What is that radius? What's that distance? So it's going to be x squared minus -2. Why is it x squared minus? It's the same thing you just said. Plus what? X. You said it. I'm agreeing with you. It's x squared plus what? 2. Because what is this distance right here that I'm drawing right there? What's that distance? That's x squared, right? But what's this distance right here? 2. This distance is x squared, and this distance is what? 2. So what's the distance from here to here? X squared plus 2. When you want to find the distance between 5 and 3, what do you do with the numbers 5 and 3? You subtract them. 5 minus 3 is 2. What's the distance from 5 to -2? 5 minus -2, which is 5 plus 2, right? You're subtracting -2, which is adding. So in this case, you've just extended the radius. In this case, you've extended the radius. So you have pi times x squared plus 2 squared from 0 to 3 dx. Now, there's only one way you can integrate this by hand. This is what I'd be looking for if I asked you for the integral. Can you use U-substitution on this one? What do you think? I'm asking, yes, you can always use your calculator, but I'm trying to show you why you have to use your calculator in this case. Why you have to use your calculator. Can anybody tell me why you have to use your calculator in this case? Or not, excuse me, why you can't use W substitution. What's the problem when you try to find a W? There's no derivative of any pick you have, right? Like if you pick, like Nick, if you pick x squared plus 2, what's the derivative of x squared plus 2? 2x. You see a 2x anywhere? X anywhere? No. So what should you do to this one? You can do this one without a calculator. What would you use? What method would you use? Maybe with an E? You would expand this. Could you multiply this out? Yeah. You could multiply this out. We're not going to, but do you feel comfortable that you could multiply that out and find the integral? Yeah, I think you are quite fine with that. But it's what is most important to me right now, the picture and the integral. The picture and the integral are what's most important to me right now. That's what's most important to me right now. So why don't you, actually, so we have a couple minutes here, why don't you try doing that one by hand right there, the blue integral. Do that by hand, please. Denominator, so 48 turns into 240 over 5. So what is that? So pi 243 over pi plus 240 over 5. Is that correct? Think so? How'd I do? 483 pi over 5. I think that's right.